Let's talk about setting the resistor values of your amplifier stages. So the ratio of your resistor values are going to be set by your gain. So if I change the gain, you can see how that R1 is changing. The ratio between R2 and R1 is changing. To change the absolute values of these resistors, I use this slider. So you can see as I move this slider, it's changing these values. You can also see as I get into the higher, into the mega ohms here for this particular part, you're seeing this big old peak. And this peak is an indication of instability. You don't want to be operating the part with a peak like this. This is a no-no. And what's happening is that there is capacitance on this node, capacitance to ground, and these resistors are driving that capacitance, and they're forming a low-pass filter. A low-pass filter has a pole. That pole is in the feedback loop, and so your feedback has this extra pole, and so as you approach 0 dB, maybe you have close to 180-degree phase shift, and you're getting this peak. So there's a few things that you can do to avoid having this peaking. So one is obviously to just use lower value resistors. If you want to use bigger value resistors, you can put a capacitance in parallel with that feedback resistor. Typically doesn't require that much capacitance, and that'll knock that down. So what's happening is now, instead of driving that at high frequencies, you can drive that capacitance directly through this capacitor rather than going through this resistor, and that stops that low pass filter action. The other thing is that higher gains typically are more robust than lower ones. So we've been using a gain of 2, which is a painful gain for this sort of stuff. If I go to like a gain of 20, you can see it's far, far more robust than the lower gains. This is typically more of a problem with higher speed parts. So let's go, I'm going to pick something that looks pretty good with this 4098, and it's about a megahertz type part, so megahertz. And so now I'm going to go look for a higher speed. Let's take this 4807 that is 200 megahertz, and you can see with the same resistors now I'm getting this huge peak, and we really need to go to a lot lower resistors in order for this to work. So we've talked about why you don't want to use too big of resistor values. Let's talk about not using too low, too small resistor values. So I want to pick a slow part that doesn't have much power. So this is a good illustrative part here. Okay, so this LTC 2064 is very low power consumption, doesn't have a lot of drive capability, and so it wants to have big value resistors. So it's happy in this region. And as you can see, as I move my resistors smaller, you can see how that bandwidth curve is dropping, dropping, dropping. And I wouldn't read too much into using the part in this region. You're kind of on the edge of the simulation capability at that point. What you really just want to take away from this is it's not a good idea to use the part in this region. You're probably going to get a bunch of distortion. The part isn't really designed for it here. So try to stay, when you're seeing that the bandwidth is dropping way below what the part is spec'd, try to avoid that and work in the region with the higher resistors. So this is, when you're using a low power part, be aware of that behavior.